The winter holidays have arrived and I have some free time on my hands, and I thought, what better way to spend this time but to build my own custom keyboard. I mean, how hard can it really be? It's gonna be a kit, and I already have a lot of experience working with electronics. I have a lot of experience soldering. I know my way around PCBs and components, and it's gonna be a fun, lightweight thing to do over the holidays, so why not? Or so I thought. This video is a documentation of my experience building the Aurora Sofle version 2 revision 1 from splitkb. It's a pretty nice kit, to be honest, and it's a lovely columnar split ergonomic keyboard with the Choc profile. I'm gonna show you the build process end to end, starting from the PCB all the way to finishing the full assembly. I'm gonna tell you why I have 2 keys right here missing. I'm gonna show you all of the fun stuff that I've discovered along the way. And I mean fun in a very sarcastic tone. I'm gonna discuss a little bit some of the troubleshooting that I've done to identify the problems after finishing the build, and why, if you are expecting this to be, you know, a very lightweight, half a day type of project, you are so wrong. At the end of this video, I hope you will be more informed than what I was if you're gonna start your own journey building custom keyboards. And hopefully you'll avoid doing the mistakes that I have done, and you're gonna have a much smoother experience than I have. Is it worth it? I'm gonna tell you at the end of the video. So stick around and let's get started. We all love a pretty nice unboxing, so let's go ahead with it. This kit is pretty neat. It arrived within 1 or 2 days of ordering it. Granted, I am based in the Netherlands and the company is also in the Netherlands, so shipping doesn't take a lot of time. In Europe or internationally, it might take a little bit longer. You can see here all of the parts came in without any damage. They're pretty nicely isolated. This is the PCB and the diodes. They came in as part of one pack. These are the top plates for the keyboard. They're made of aluminium. This might be problematic a bit down the line. I'm going to talk a little bit more about that. This is the rest of the components, along with a small, sugary snack. You can see here we have the OLED displays, the TRRS cable. You have the Milmax hot swap sockets. You have the microcontroller. So you pretty much got everything you really need to assemble this keyboard. It was a pretty easy setup. I didn't need anything else. It all came part of the main package. As part of the package comes, a couple of frosted acrylic plates to be used as the bottom of the keyboard. And of course, the Kailh low profile switches. I ordered the burnt orange version, which are tactile with a bit more extra force to press. I don't necessarily like these, to be honest. I would have preferred a little bit less force, but I thought more force would make it a bit more, the feel of the keyboard would be better, but that might not necessarily be the case. It really depends. You have to try them out before you really figure out which ones are best for you. And lastly, we got the MBK Choc Glow keycaps. They are of a white color. They are ABS plastic. They are also translucent, so the glow from the RGBs can actually pass through them. They have a pretty flat profile, so they might need some getting used to if you are already using other chunkier profiles. Before we begin soldering and ruining our desk, it's very important to use a soldering mat, which can take heat up to 500 degrees. This is the one I'm using. It has also compartments where I can put my components, which I then avoid losing. This is a great mat. Now, you can see me here detaching my diodes and bending their legs because I am using through-hole diodes, which means that they're gonna go through holes in the PCB from one end to the other, and then you would basically solder them on whichever end makes more sense for your setup and your build. As you can see here, the direction of the diodes is extremely important. If you put the diodes in the opposite direction, they're going to allow the current to flow, which is going to break your keyboard, and it's not going to work as intended. So triple check, because what you don't want to do is you don't want to desolder these diodes after you fix them on the PCB. It's a very painful process to desolder anything. And you definitely want to take the time to inspect your setup before making anything sort of permanent. A lot of the pain you're going to face in your builds is when you make a mistake and you have to recover from that mistake. Very few mistakes are not completely recoverable. Sometimes you ruin a component and you need to, install another one, but that's going to delay your build. And this is what's going to make your build take days as opposed to hours. Now, you can see here that my soldering technique is not good. And the reason for that is when you want to solder, you want to heat up the joint on the PCB. You want to heat up the leg of the component, and you want to heat up the solder so that everything gets detached and flows in the proper place. You can see here in this view the improper joints and improper soldering, how it looks like. Some of them are okay, the majority are not, and you want to avoid making these mistakes. It's just a technique that you have to learn over time, and once you master it, this is the key trick for it. Heat up everything, and then you're gonna have nice soldered joints that look somewhat like this. This is not what my board looks like. This is an example from the build guide, and look how small, tiny, the joints are. And when you clip the legs, things are gonna be quite smooth and pretty nice, neatly set up. Now, you can see me here straightening the legs of the diodes. I already bent them when I inserted the diodes because I wanted them to stay in their place. But now is the time when I need to solder them. And I don't want to solder the legs when they are bent because this is going to force me to use excess solder, which is not going to look good. I bend them straight because this allows the solder to flow down and connect very nicely to the board. Now, this is where I also made my first and very important mistake. I'm using a low Choc profile, which means that the diode legs are gonna hit the metallic aluminum plate of the top of the board, right? And no matter how thinly you cut these diode legs, the clearance between the PCB the clearance between the PCB top and the aluminum board is very, very, very low, which means that there's going to be short circuiting that's going to happen. There is a way to fix this, which is using SMD diodes, but these are much more painful to install. And the other way to fix it is by flipping the diodes. So instead of soldering the diodes from the bottom and have the legs push up, you would solder the diodes from the top, and you will have their legs pushed down in the opposite direction of your metal aluminum plate. This honestly caused me a lot of pain in troubleshooting failures with the keyboard later on, and unfortunately, this is something very, very tricky to recover from, especially after you solder the switches, like I did. Next up, we have the RGB LEDs for each key. Now, if this is your first build, I recommend that you skip this step. I know RGBs make the keyboard look nicer and cooler, and you can have a lot of effects which can come in handy. However, these are a lot of pain to solder because they're so tiny, very fragile, very sensitive to heat. You're gonna have to make sure that their positioning and alignment is proper. There is a very specific way to install them, and you cannot really solder all of the legs at the same time. You have to do one leg and then move on to all of the other LEDs and then come back because they are heat sensitive. So there's really no gotchas here. It's just a very annoying process to go through. If this is your first build, it can take quite some time. As you can see here, I've done it for my first plate or first PCB, and then I'm gonna do it again for the second half. And this is a process that took many, many, many hours for me. And you will never know whether you've done a good job or not until the very end, when you turn on your keyboard and see if the lights go on or off. In addition to soldering your diodes and your per key RGB LEDs, you would also want to solder the resistors, the TRRS jack, as well as the reset button. These are quite easy. There's really no fuss about them. The placement is very clear, and there are no gotchas with these components. Now, next up, we have the microcontroller. It really varies which microcontroller you will be using with your kit. I'm using a Liatris microcontroller over here with header pins, and this is where I made my second mistake. These header pins are easy to install. If you remember what I told you about soldering joints, that you need to heat up all of the different elements, you know, the leg, the PCB joint, and the solder, you should be good to go. It's just a repetitive thing. Normally what I like to do is I like to solder one pin at one end, and then I will want to work on the pin from the other end just to make sure that the header pins are vertical or perpendicular to the PCB itself or to the microcontroller, and that it's not, you know, turning or pitching in a wrong direction. I want to make sure that they are properly aligned. And if I solder it this way, I can, you know, easily, you know, fix the alignment. by just desoldering one end and moving it a little bit until I have the perfect positioning. Once that is done, you can solder all of the rest of the pins, and this way you have your header pins attached to your microcontroller, and then you can proceed to the next step. Now, what is the mistake here? The mistake is later on, I'm going to show you how I soldered the microcontroller itself on the PCB. I would not recommend that you do this. I would recommend that you socket your microcontroller. Basically, you can get female header pins where the pins of this controller can go into, and then you would solder these female header pins to the PCB itself so that you can easily insert and remove the microcontroller. Why is this important? And something I did not pay attention to from the beginning is that these microcontrollers can often fail, right? And you would want a mechanism to easily replace them. If you solder the microcontroller on your PCB, as you see here where I fitted it onto my PCB, you're going to have a very hard time removing it later on. You're going to have to desolder it. And again, whenever it comes to desoldering, you want to avoid this like the plague. You want to make your life much easier. So you know now that there is an option for you to do that. And I would recommend you go down a socketed route as opposed to following this setup yourself. Now, we didn't start the soldering process of the microcontroller on the PCB itself because I want to first make sure that the microcontroller works. This is very important. So what you would want to do is you want to connect your microcontroller via USB-C to your machine and make sure that it actually starts and boots up. And you can see from the red or orange, whatever the color is, LED on the microcontroller that it is up and running. At this point in time, also, these microcontrollers are set up so that they connect as an external disk to your machine. There is firmware that comes part of the kit that you can just download and copy the file, install it on the microcontroller's disk, and the microcontroller will automatically eject itself and install that firmware. And this way you would have flashed your microcontroller and you would have installed the default layout of the keyboard as well as the default firmware that's going to make sure that everything else works as intended when you install this microcontroller on your PCB. Now, obviously, later on, you would want to customize this layout with the help of QMK or ZMK or any other firmware that you're going to be using. You can reflash or flash this microcontroller as many times as you want to install new key layouts or to customize the firmware whichever way you want. Next, what I'm doing here is I'm soldering the microcontroller on my PCB, which again is the step that I do not recommend. I have used a little bit of heat resistance tape so that I can, fix the microcontroller in its place. This tape, you can buy it, it's very cheap. It doesn't burn and it doesn't melt with high temperature. Now comes the time to install the switches. You can see here we have the aluminum top of the keyboard. This is where my biggest first mistake materializes, and you're gonna see why in a second. But you first check that it's a good fit on the PCB. This plate is gonna be very, very close to the PCB. And if you remember at the beginning, I talked about the legs of the diode. This is where the problem lies. The legs of the diode will be facing this metal plate from the top, or from the bottom of the metal plate, and then it's going to be touching that metal plate and it's going to be shorting the whole board, which means that whenever I press a certain key, it's going to act as if it's pressing multiple other keys at the same time. And this is very, very painful to fix. This is what you want to pay attention to from the beginning. Now, you can fix the switches directly onto this metal case. It's a very easy process, but you need to make sure that you don't break your switches while doing so. Just grab one of them and try to fit it into one of the holes. And what you would want to do is with your tweezers, you would want to gently push some of these edges of the switch and press gently on top of it so that it clicks into its place. When you hear that click, that means that the switch has been properly inserted. And all the way when you are trying to do this, try to fit this case along with the switches onto the PCB and make sure that the legs of the pins of the switch fit into their proper position. Sometimes the legs of these switches are bent. Use your tweezers to gently push them back into position. Don't be too afraid of that. But don't do it too much, otherwise they're gonna break, and if they break, the switch is done. You're gonna have to throw it away and use another one, and you might not have extra switches to use. So always make sure that the legs are properly aligned, and then make sure that they fall into place onto the PCB. You can see here I'm testing that quite thoroughly. Now, my recommendation for this part is, instead of soldering the switches directly onto the PCB, which is going to cause a lot of problems for you if you break something or you want to fix something a little bit later. This is a semi-permanent thing, that you would buy the hot swappable sockets. You would solder the hot swappable sockets onto your PCB, and then you would install or you fit the switches into them, which means that you can easily take them out if you need to, and then you will be able to easily detach the PCB from that top metal plate of the keyboard. I didn't do this. It was not really recommended when I bought the kit. It's one of the things I deeply regret doing, which is, you know, soldering the switches onto my PCB, but it's done right now. You can desolder them, right? You can, but it's a very intimidating process, especially for a beginner, and it's also a very time-consuming thing to do. And at the same time, you might break a lot of the joints on the PCB itself. Then you're gonna have to create some bridges, which I'm gonna show you towards the end when I start talking about the troubleshooting steps that I've gone through to make sure that this keyboard is fully functional as it's supposed to be. Be careful of that. Buy hot swappable switches. Buy stuff that will make your life much easier. There are a bunch of them. All right, next up, we're going to continue assembling the case. Here you can see me installing some spacers. These are going to come in handy because we want to install the bottom, the acrylic bottom of the keyboard. And these spacers will create some distance between the PCB, the bottom of the switches, and the back of the case. And you can see me here using the screws that come all part of the kit along with the spacers to install the acrylic back of the kit. Now we are ready to install the OLED displays. This is a very easy process because we already soldered the OLED sockets. So it's just a matter of fitting the, the pins in their place. And then you can see me here connecting the keyboard for the first time. This is the first trial. I've connected the TRS jack to both ends. And then I connected the USB cable to one of the keyboard sides. Now the microcontroller firmware is pretty cool because once you connect the cable to the first microcontroller, it will designate itself as the primary, and then immediately when you connect the TRS cable to the second one, it's gonna designate it as the secondary. So there's really no need for you to do any configuration changes. This is all done automatically whenever you run your keyboard for the first time. But as you can see here, I have a bunch of LEDs that did not really start. There are problems with the keyboard. A lot of the keys are not working at this point. And this is one of the moments where you are testing the keyboard for the first time. And this is when, if this is your first build, you're gonna feel like, oh, I messed it up. Now I really don't know how to proceed from here. You're gonna have to start going through the troubleshooting guides, and you're gonna have to start diagnosing what really went wrong in your process, right? At this point in time, I've already invested about 10 hours into this build, 10 or 11 hours into this build. I was very tired, and I would recommend that you don't do any troubleshooting at this point in time because you're not gonna be able to think clearly, and then you're gonna start messing up your setup way more than what you would be actually fixing it, right? I would highly recommend that you take a break and then you come back to this build definitely at a later point in time to start troubleshooting the problems that will definitely arise, especially if this is your first build and you don't have a lot of experience with constructing keyboards from scratch. Now, a couple of things I had to do while troubleshooting this build and trying to fix it is, remember I told you that the metal case at the top is very close to the PCB. I had to install some spacers, something in between the PCB and the metal plate over here to create some distance and to prevent the diodes from actually connecting with the metal plate and shorting my keyboard. You see that the diodes are installed from the bottom and then their legs will touch the metal plate on this end. This is very, very problematic. And you would want to avoid this problem by using SMD diodes as opposed to through-hole diodes like I did, especially if you are going for a Choc profile. This is not a problem when you are using a thicker profile. And then the second thing I did, which is I ruined a few of my switches. And you can see here that I've also ripped off some of the joints. I'm not sure if it's very clear, but because of this, I had to install some bridges on the PCB itself. So this is the time when you're gonna need a multimeter, because you're gonna need to check for continuity. You're gonna need to check for shorting of your keyboard. And then what you would want to do is, if you have ripped off some of these, joints like I did, you're gonna have to connect these areas with external wires. I've used regular solder to connect them, and I've isolated them with some isolation tape. But you can use, jumper cables also. This could be a viable option for fixing that. This is a normal part of the process, and this is what I think you should be very clear about at the beginning when you start your custom build, that this is not going to be a few hours type of activity, especially if this is the first time you do it. This is definitely going to be a multi-day project. You might also need to order new components, because in my build and in my experience, I have definitely made the mistakes that I told you about, and these have caused me to break a couple of switches. They have caused me to ruin a couple of RGB LEDs, and they have caused me to ruin also some of the diodes that I had to replace. And then I had to put in a new order for new switches, new diodes, and new RGB LEDs. Things could be a bit worse. For example, your microcontroller might not work from the first try. You might need to order a new one. Or you might even, break your microcontroller while you're trying to flash it, and then you're going to have to put in an order for a new one. So make sure that whenever you start tackling this project, you put aside a good chunk of time, a few days, for you to be able to finish this project end to end. Now, while I'm sharing with you some footage of me relearning how to type, because the layout is so different, your WPM is going to drop from the hundreds to the single digits. Mine dropped from 133 words per minute to about 9 or 8 because this is the first time I use this type of layout, and it's gonna need some adjustment. So you need to take that into consideration as well. This keyboard is not gonna be something that you can get used to like within a few minutes of starting to use it. Now, my genuine thoughts on the whole process are as follows. Number 1, would I do it again? Yes. So even though this was a very painful first build for me, there were a lot of mistakes that I've done that I did not really anticipate. Some of them were in the docs and the build instructions. Some of them were not. Some of them were not really expected by me. And some of them are mistakes that I've done because I was a bit tired. And then I wanted to rush things. So if you expect that this is going to be a few hours type of exercise when you buy the kit, then trust me, you're not going to have a good time. You need to think of this as a multi-day, maybe even multi-week project, depending on your skill level and depending on the equipment you have. It's going to say that you're going to need bare minimum equipment, but in my opinion, you're going to need a soldering gun. You're probably going to need some tweezers if you don't have them. You're going to need some screwdrivers. You're going to need some, heat-resistant tape. You're probably going to need to order some extra components yourself. You're definitely going to need the multimeter for troubleshooting problems. Even if, everything goes perfectly, you're still going to want to check for continuity, for shorting here and there. Not a lot of things are going to work right off the shelf. Or, it depends if you are lucky and if you don't make any mistakes at all, but that is highly unlikely. The cost is something you also need to keep in mind. This is not a cheap kit to buy. This is the breakdown of how much this whole kit has costed me. And this is not to mention the equipment that I have to buy, but I'm not going to mention the equipment because this is stuff that I'm going to buy for this project and for potentially others. This is not a cheap hobby at all. I'm not sure if you can even find these kits at a way cheaper rate because these are made to order often, and even if they're not made to order, there's not a huge demand for a lot of these kits, so prices have to go a little bit up. Now, do you need any electronics experience prior to, this build? I would say you be the judge of that. It really depends on your tolerance and how much you would want to explore in this realm. Keyboards are not necessarily sophisticated in any way. They have a very simple schematic. And once you understand a little bit how the components are represented, you can read the schematic of the keyboard. A lot of this stuff is already open source, so you'll find it in GitHub repositories. Not a lot of this is closed source by any means. and there's a lot of awesome communities. So splitkb have a great Discord server. The people there are very, very helpful. If you share some screenshots of the process, where you are in the build, and some of the problems that you are facing, a lot of people will come in, jump to help, and offer some guidance. They will even share with you some references that you might want to read and dig deeper into. Also, there's plenty of material online in terms of YouTube videos that will show you how to solder, how to clean up your solder, how to desolder components, how to, troubleshoot problems, how to bridge connections if they are broken. And because the PCB layout is quite simple, bridging is actually a very simple exercise to do, even if you break some of these components yourself. So if you keep all of these things in mind, this is definitely a project that you will enjoy. I know for a fact that I'm going to enjoy my next build way more than I enjoyed my first one, because now I know some of the mistakes that I might fall into, and now I can better prepare for my next kit, which I'm able to customize a little bit better to fit my needs. Unfortunately, with this hobby, and pretty much any hobby actually, is you have to invest some of your time and effort and money for you to feel if this is really for you, and whether the value added or the value benefits that you're gonna get are equal to the costs that you're gonna put into this hobby, right? I mean, are there any really cheap hobbies nowadays? Everything will cost some money. And then at the end of the day, you can get the bragging rights. You built your own keyboard. You can tell people that you've done that. It's something that will raise some eyebrows, and people might be all like, oh, this is awesome. You've gone to the next level. So why not? It has its benefits, right? It's pretty cool. Not a lot of people can say that they've built their own or assembled at least their own keyboard. All right, enough about keyboards. I hope you enjoyed this guide, and I hope it will help you avoid some of the mistakes that I've done and prepare you mentally for what to expect when you're building your first keyboard. Now I'm gonna go continue learning how to type, and I will catch you next time. Thank you very much for watching.